Okay, if you remember, there are a few terms that I want to show you guys. If it is if a number is in the form of A over B, right? Um, um, this is the numerator, right? This is numerator. And the bottom one is the denominator. It's denominator, right? Okay, so this is the denominator. Okay, and the top one is numerator in a rational form. This is what we have. And sometimes what happens is it is not easy to, or mathematically it's not easy to, find a definite answer, as in a perfect rational number. For instance, if it is like, I don't know, 4 over 2, you would end up with 2. Or if you're even 5 over 2 even, you would have a definite answer here, right? But in some cases, that's not the case, right? That's not the case because in some cases, you would end up with something that has the denominator having a radical, or a square root format. In that case, you would apply this method, rationalizing numerator and denominator method. Okay, and I'm going to show you how to do that. Okay, well, in order to do those things, one terminology you guys probably are familiar with is the conjugate. Conjugate. What is that? That is what that is another term is inverse relation uh, to any expression. For instance, for the expression x squared minus x squared, well, x plus x plus root a. Okay, for this expression, the inverse relation to this would be x minus square root of a, right? So this here is the conjugate to this expression. So this is what we use to rationalize what's not a rational number. Okay? What we do is we multiply both the numerator and the denominator by 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 the conjugate. Okay, simply that's how you do it. Okay, it's very simple, very easy to do. All you have to do is just apply those. Okay, okay, let's do an example that might help in this situation. Okay, example would be 2x over the square root of x minus 2. See, how are you going to calculate this in its simplest form? So you would plug in numbers to find the value of x, or do some other operations. This would disable that step unless you rationalize the bottom denominator. And just like I said before, what you would do is find out the conjugate of the given expression and then try to go from there. And the rest would be absolutely easy to do. Okay, so multiply the expression on top and bottom by the conjugate. Okay, multiply this by root x plus 2 over, again, root x plus 2. Okay, see how I did it? It's very simple, it's very easy to do. Okay, so after this is all operation and simple basic mathematics. End up with 4x. It's 4. Okay, what you do is just after you apply the multiplication rule for rational numbers. That's what you do here, right? 2x times root x plus 2, and for the top part and for the bottom part you do root x minus 2 times root x plus 2. That's what you do, and you end up with this, and then the rest is simple. We'll have to just plug in everything, and that's it. You're in. You're set, right? That's how you do it. And I will also add one more example to this, so you would have a little bit of more understanding of how you rationalize a numerator and denominators. Okay. Okay, sometimes you might end up with the reason why I include a numerator is because sometimes you also find radical expressions on the numerator as opposed to the denominator. In those cases as well, you do try to simplify by applying this method. Okay, stay tuned for another video for example number 2. Okay, but if this is helpful, please subscribe and like, and I will see you on my next video.